Hey everybody, welcome back. Today we're going to be doing RC circuits. For this lab, your students will need a DC power supply, a digital voltmeter, and one of our handy dandy RC circuit boards. Students will set their digital voltmeters for channel 1 for 5 volts, VSET 5 point, no more than 500 milliamps. Students will power their board by connecting the banana plugs to the terminals, red and black, and they can output like so. Now the circuit is set up to terminate in discharge mode, and charge will close the circuit and begin charging the capacitor. For the first part of the lab, students are going to measure it very roughly. They're going to use a digital voltmeter set to DCV 20 volts. They can leave it there for the entire lab. And 2 banana plugs found at your station and probe the voltage across the capacitor. When they complete the circuit by hitting charge, the capacitor will begin to charge. They will then count with a stopwatch that they will use their phone or a computer program to count the number of seconds it takes to reach 2.5 volts, or half the voltage, therefore measuring the half-life. This is a very rough method of doing it, and for the second part of the lab, they're actually going to take a series of data and linearize it to calculate the voltage. So let's do that now. So I'll discharge the capacitor. You can also quickly discharge the capacitor by using a jumper wire provided, and just quickly discharge the capacitor. For the second part of the lab, students will be asked to take data every 5 seconds as the capacitor charges and discharges. They will then use this data and linearize it using the log function to get a better fit and calculate the half-life that way. Please have one student flip the switch to charge the capacitor and read the voltages, and the other student write them down on a spreadsheet as they're saying them out loud. For the final part of the lab, students are going to get a very accurate fit of the charging of a capacitor. They will use their Logger Pro software and hook up a differential voltage probe across the capacitor. Begin collecting data and charge the capacitor as a function of time. Once a period of time has gone by, it takes approximately 30 seconds to charge fully. They'll do an exponential fit of this data and get their tau coefficient. The program's set to run for 70 seconds. After 70 seconds has gone by, they can select from where their data started to the end, use the f of x equals to fit a function. They'll choose to fit an exponential, a e to the negative ct plus b. Try fit. OK. You can see their fit parameters, and their exponent, c, is going to correspond to their tau value, or RC, or 1 over RC. So here we have a tau value of 0.08. That should be about the same for all the boards. If they're getting anything different, call a tech. This is a really fantastic lab. Not only do they learn about charging and discharging of capacitors and the half-life time, they also get to do a little bit of error analysis, measuring it 3 different ways and seeing which ways are the best, most accurate ways to measure. Thank you.